Well, welcome back to our seventh and final episode in this series of lectures on relational databases and relational database constraints. We're going to discuss some of the operations that take place in a database and how those operations might impact the constraints that exist in the relational database. So let's get started. The insert operation provides a list of attributes for a new tuple that's to be inserted into a relation. Insert can violate any of the four types of constraints discussed in the previous section. Domains can be violated if a given value does not appear in the corresponding domain or is not the appropriate data type. Key constraints can be violated if a key value in the new tuple already exists in another tuple in the relation. If you take a look at our slide, you'll see that each tuple in the employee table has a unique value. There is a SSN attribute that's been identified as its primary key, and that SSN attribute in itself ensures that there is no key constraint being violated here. The same can be said for the department relation. The D number is a unique value, and as a result, every tuple in the relation is unique. Same with the department locations. Entity integrity can be violated if any part of the primary key of the new tuple is null. Let's look at the next slide. Work zone relationship has an ESSN and a PNO together make up the primary key. The primary key, of course, as we already know, makes every tuple unique. In this case, if either one of these values were left null, you would be violating the key constraint. Same can be said for the dependent relation right here. ESSN and dependent name together make up the primary key. If either one of them is left null, you're violating the entity integrity constraint. Referential integrity can be violated if the value of any foreign key in the new tuple refers to a tuple that does not exist in the referenced relation. Well, let's go back and take a look at a couple of these. Here we have the employee table, and the employee table has a foreign key called DNO, which references the department table's D number. If there were a value placed in here that would not be found in here, it would be a violation of referential integrity. It is acceptable to have a null value here. In other words, the entity integrity constraint states that if a value exists here, it must exist here, or it can be left blank. The same can be said for the department locations table. The department number here must exist over here. But in this case, the department number cannot be null because it is part of the primary key of the department locations relation. Take a look at the next slide. We have a multi-attribute primary key here. So if either one of these is left null, it's a violation of the entity integrity constraint. The default operation in any of these cases where a constraint is being violated is to reject the insertion, not allow it to happen. Now in the delete operation, one can only violate the referential integrity constraint. This occurs if the tuple being deleted is referenced by foreign keys from other tuples in the database. Let's go back and take a look at our examples. If we try to delete the record for research, which is department number 5, we would be violating the referential integrity constraint because the employee table is referring to department number 5. In the next slide, we'll find that the product X and product Y and product Z all refer to that department number. Therefore, to try and delete research would be a violation of the referential integrity constraint. There are several options available if a deletion operation causes a violation. First option is to restrict, that is to say, reject the deletion. The second option, called cascade, is to attempt to cascade or propagate the deletion by deleting tuples that reference the tuple being deleted. Back to our slides up here. If we try to delete research, we either reject that or we delete research and then delete every tuple that refers to research on both of these slides. Probably not a good idea as a general rule. Third option is to set null or set default, which is to modify the referencing attribute values that cause the violation. Each such value, such as this one, and this one, could be set to null, or it could be set to reference one of the other departments. That's an option. But once again, if the referring attribute that causes a violation, like here, is part of the primary key, it can't be set to null, such as in this case right here. So that third option is not available in this particular case. Combinations of all three options are possible. The update operation is used to change the values of one or more attributes in a tuple of some relation. Updating an attribute that's neither part of a primary key nor of a foreign key usually causes no problems. The database management system needs only to check to confirm that the new value is of the correct data type and domain. Modifying a primary key value is similar to deleting one tuple and inserting another in its place, because we use the primary key to identify tuples. So to review, in the insert operation, one can violate any of the four types of constraints. If the insertion violates any of these constraints, the default option is to reject. The delete operation only violates referential integrity, and the options are to restrict, which is to reject it. The second option is to cascade the deletion, that is to say, take out not only that tuple but every referring tuple in all the other tables. And then the third option is to set the referring tuple to null. It's also possible to give the referring tuple a different value so that it refers to one of the other tuples in the relation. In the update operation, if it's not part of the primary or the foreign key, we're probably good to go. A database application program running against a relational database typically executes one or more transactions. A transaction is an executing program that includes some database operations, such as reading from a database or applying insertions, deletions, or updates to the database. At the end of the transaction, it must leave the database in a valid state that satisfies all the constraints specified on the database schema. A single transaction may involve any number of retrieval operations and any number of update operations. These retrievals and updates will together form an atomic unit of work against the database. For example, a transaction to apply a bank withdrawal will typically read the user's account record, check if there's sufficient balance, and then update the record by the withdrawal amount. A number of commercial applications running against relational databases in online transaction processing systems are executing transactions at rates that reach several hundred per second. So there we go. That concludes our discussion of relational databases and relational database constraints. Well, that does it. There was a lot of meat in this series of lectures on relational databases, so we need to spend some time reviewing all the videos and the material that we discussed, because we're going to be applying that as we start building our own databases in this class, and we'll really need to know this material. Okay, we haven't selected a mystery word this time, have we? Why don't we use the acronym for Online Transaction Processing, OLTP. That'll be our mystery word this time. Go ahead, submit your mystery word, go out to our coursework area and check your knowledge on the material we just covered. And then you might want to review all of those check your knowledge assignments to make sure that you have a good grasp on this material. I believe in our next series we will explore SQL. See you then.